Okay. Hi, everyone. Thanks for being here. I'm excited to be here. And as was mentioned by the chairperson here, I will be speaking in English, but I have a lot of experience speaking in English in Japan. So I hope I will be nice to you, and I hope you will try your best to keep up with me. The title of my talk is The Complex Primate. So some of my stuff is complex. I'll try to break it down. But before I start, I would like to thank the organizers of this ELCAS program. I think it's a really nice initiative for Kyoto University, and it's great for me to have a chance to see all of you guys so young. Makes me remember, I can barely remember when I was that young as well. But it is really exciting to be able to communicate to this kind of audience. And I hope that, some of my presentation will be boring, but I hope that enough of it is exciting for at least some of you to try and encourage everybody to get into science. Science is so cool. There's so much that we can do. Okay, and so I'm going to follow up a little bit on President Yamagiwa's talk and fieldwork, and also primates, and try to also touch a lot of different fields of science, okay, as I go through. Which way do I go? So I have always been interested in the natural world, all right? And the natural world shows us many amazing things. So I'll be talking about a lot of amazing things in this hour. But 3 pictures up on the screen right now, they're all pretty amazing things, and they're all part of the natural world. But they're really hard to understand. So in the first image, on the left side, you see a school of fish. A school of fish performs amazing behavior as a unit, okay? It's like if everybody in this room, the ELCAS unit, decided to get up and run around in the same direction with each other, you might do something that looks like a school of fish. But remember, a school of fish is not really talking to each other. Nobody is telling them to swim around in a collective unit like that. Yet, a school of fish can display some beautiful patterns in nature to escape predators and generally to move around. All right? Difficult to understand. In the center, we have a murmuration. It's called a murmuration of starlings, European starlings. Same thing, beautiful patterns in nature. All of the birds coordinated together, but not talking to each other, okay? Just doing similar things, following simple rules, creating amazing patterns. The last one is, anybody been to Africa? Anybody seen any termite mounds before? This is a termite mound. Shiroari creates it, okay, with very simple behavior. But the final product is really amazing, okay? We look at this in nature, it's fantastic. It's amazing to think such a small animal with a very small brain, okay? But a lot of individuals can do things like that. So I'm interested in how these patterns in nature evolve and appear, all right? And so in this talk, I have a couple of central concepts, okay? And the first concept here is that, so I am a behavioral ecologist. It means I study animal behavior and I study ecology. And in those fields, we know a lot about what an individual fish does, how it moves, how it swims, how it mates, how it finds food. We don't know much about how a school of fish behaves together, although we're starting to know more and more of that now. So actually, complexity is one of the last major areas in my field of science, okay? Nature is complex. So in this talk, I'm going to talk about 2 things. The first one is called behavioral organization. How are all of these animals organized together in a way that creates these incredible complex patterns? And the second thing is about nonlinear dynamics. Nonlinear dynamics, maybe some of you have heard of chaos theory or fractals. Those are the things I'll be talking about and how they relate to behavior and ecology, okay? Okay, so just coming back to my title, those are the two things: chaos, nonlinear dynamics, fractals, and animal behavior. And the second one, if we go back for a second to this image, this is a lot of different fish. This is a lot of different birds, and a lot of termites make this mound. They all interact together in social networks, okay? And so the second part of my talk is actually about how information or anything moves between individuals in a social network. I'll try and put these two topics together. They're very different, but they're also all based on complexity in the natural world.